Everybody, welcome to another Weaveworks office hours event. We're going to get started in just a couple minutes. We'll give people a little time to arrive and get connected. Today, we're talking about EKS a really great open source tool that we built in partnership with AWS to make creating clusters in EKS simple, easy, and reliable. So hang with us for just a couple minutes and we'll get going. For everybody showing up, we're going to get started in about 1 minute. Just wanted to give everybody a chance to join. And apologies, I've got internet connectivity issues, the joys of working remotely. So no camera from me today, which is great because we've got much more important stuff to show on the screen anyway. Hang tight. We'll get started in just about a minute. Ready to get going here, folks. Thanks again, everybody. This is Weaveworks Office Hours. Happy Wednesday. I hope you're having a great day.
Oh, Joe, I think we lost you. That internet connectivity. Let's give it a second. Okay. Shetan, would you like to kick off? I think Joe's in a bit of an internet blip. Maybe we can kick off and you can start the demo.
Sure. Hello, everyone. I'm Chetan, a senior software engineer at Weaveworks. I am a member of the EKS control team and also the leading contributor to the project. Today, I'll start by running a simple command that creates an EKS cluster. And while it's running, I'll walk through the resources it creates for you. Yeah, so this is the command that I'll run. So an EKS cluster typically takes around 8 to 10 minutes to create. So while that's happening, I can share more details on what it's doing behind the scenes. On the left side, I've opened the eksctl.io website. So what this command does is, the only options I've applied to it are the name parameter and the region. Region is optional and defaults to US West 2, but I've supplied a region because this is the region I'm currently working on. So a typical create cluster command creates a VPC and a set of subnets that are passed to the control plane and are also later used to pass to the node groups. So if you take a look here, it shows a CIDR for the VPC and split that CIDR into multiple subnets. So EKS control creates a set of both public and private subnets. well, a public so by definition, a public subnet has a, a route to an internet gateway, whereas a private one usually has a route to a NAT gateway. So the default command not only creates an EKS cluster, but it also creates a node group with 2 nodes. And by default, it launches them in public subnets, but it can be overridden using the private networking flag or the private networking field. Private net. Yep, so this will take a while. So by behind the scenes, EKS control uses cloud formation to create the resources required for the cluster. So for example, that cloud formation stack for the cluster would contain the EKS control plane resource itself, then the VPC and subnet resources, actually all networking resources, and that also includes route tables, security groups, IAM roles, everything that's required to stand up an EKS cluster. Later, when this command completes, it will also use a cloud form or create a cloud formation stack or the initial node group that is printed here. So while this is running, I can share a bit of history about the project. So EKS control was released to improve the user experience of using Amazon EKS. So when EKS was first launched, it did not have a concept of node groups. It lacked many features, and even if something as simple as adding nodes to a cluster required going through a lot of manual steps. Even the EKS console at that time mainly acted as a wrapper for the AWS API. For example, to add nodes to a cluster, there were instructions in the official EKS documentation that involved downloading or copying a CloudFormation template, filling in some variables, manually creating a CloudFormation stack using the template. And this was not enough, actually. So even after you had created the CloudFormation stack for the node group, you still had to authorize the nodes within that node group, and that required adding an entry to a Kubernetes config map called AWS auth. And even that process was a bit clunky because it required you to grab the node role for your node group and assign it or actually map it to the system nodes and system bootstrappers Kubernetes groups. And that is what enabled the nodes to join the cluster. So EKS control simplified this process by providing native or self-managed node groups. Prior to EKS control, the term node groups was not used in the EKS documentation a lot. So it's possible that EKS control was the first in the context of EKS to use this term. And yep, so it simplified the user experience by providing a single command that did all of that for you. And since then, we have been incrementally releasing new features and also keeping it up to date with new features released in EKS.
Prior to EKS control being available, there was a lot of opportunities for people to make mistakes, and there was a lot of things that they had to track and manage that are now simplified with far fewer commands that people need to remember and work with and use. Do you think that this helps contribute to organizations kind of being more consistent and having fewer misconfiguration errors and human errors in the process of standing up clusters?
Certainly. So So I believe that EKS control not only prevents you from making mistakes, it also gives you sensible security defaults. So even if you're not familiar with the entire EKS infrastructure, you would still get a cluster that follows best practices and uses the principle of least privilege.
Really great for everybody, security teams, compliance teams, overall, corporate risk. It sounds like being able to have some sensible security solutions in place, kind of baked into the way that you can spin up these clusters, can really help organizations manage and reduce their risk and prevent things like an app dev team spinning up a cluster that then becomes a security risk for the organization. So that's great that on top of not only simplifying things for the people who need to be able to create and manage these clusters, it's also helping reduce organizational risk and help companies be more compliant. And I would imagine, some of what we get from things like platform engineering approaches is removing all of the complexity and the decision-making that people need to be able to focus on what they really want to focus on, which is probably, developing great apps and software. And that sounds like a great way to help things move faster and more smoothly. Are there some additional commands that you can pass that change some of the defaults when clusters are being created?
Yeah, so the recommended way to create or manage EKS control clusters is to use what is called a cluster config file. So I'll just find an example here in the documentation.
The demo and wondering, you think it takes about 10 minutes or so to create a cluster? Of course, it depends on a lot of things on the AWS end of things and what region you're spinning it up in and all of that stuff. But more or less, kind of press the go button and get a cluster in 10 or 15 minutes.
Yeah, 10 or 12 minutes is what I would say it takes. And this is not a limitation of EKS control. It's just how long the EKS control plane takes to come out.
Well, it still sounds really fast because I've watched other people struggle to create clusters on EKS for the first time without using EKS control. And, I think people would be happy to be done in 30 minutes or an hour, right? And then still be worrying about whether everything was configured correctly. So this is not only a great time saver, but yeah, it just, one command and some flexibility in how you pass that. Sorry, back to you on other things you can pass through.
Yeah, so just to add to your point, so EKS control is not just used for managing production level clusters. It's used a lot more in CI/CD environments where you do not need to worry about having the right resources in your cluster. So having a single command makes it a lot easier. Yeah, so back to the config file. So the command that I used here uses a set of defaults that some are shown here, but after this command completes, I can show an option that prints the default config that is used to create the cluster. So not too long ago, we added a feature called dry run. I will look it up here. This collapse view may not be showing all the menu items anyway. Okay, so the cluster is created. It's now waiting for the notebook to be created. So as you can see, it also created a CloudFormation stack for the managed notebook, and it's now waiting for it to transition to the active status. So after this command completes, not only will we have a proper EKS cluster and a set of nodes stood up, it will also write a kubeconfig file to the location configured for the kubeconfig. So having that kubeconfig file lets you interact with this cluster. I will note that a common misunderstanding is that some users try to make changes to their kubeconfig file and expect EKS control to read that config, but EKS control does not work like that. It does not read any kubeconfig files from the file system, but instead it obtains the cluster CA and the API server endpoint from the EKS API itself. So any changes made to kubeconfig files will not be reflected in EKS controls operation. So this should be done in a minute, I would say. Oh, so the cluster is now ready. You notice this log line, it says that the kubeconfig file was updated with this cluster. So go ahead and do this. And should see two nodes that are ready. Oh, okay, so so on the website, we have a lot of features that are listed here. I'll jump to one that is one of the most commonly used features, which is add-ons. So when I created this cluster, it created the EKS control plane creates self-managed add-ons for kubeproxy, CodeDNS, and the AWS CNI plugin. But some time ago, EKS launched a new add-ons feature where EKS manages the add-ons for you. So to enable that feature, all you do is specify the add-on name under the add-ons field. One thing of interest, so this has a lot of config hits, not required for creating the VPC CNI add-on. All you need to do is apply just name and the version. These policies are actually, most of them are the default, so we do not need that. I will note a security feature that is being used here. It's called IAM rules for service accounts. It's not explicitly listed here. There's a another section that talks about it more, but what's happening here is that so this VPC CNI plugin needs to query, needs to access AWS resources, for example, to query the elastic network interfaces in your VPC and so on. So the way this works is that your EKS cluster has an OIDC provider associated. You have to set this field to true. And with this IAM roles for service accounts feature, this add-on is able to access AWS resources. This add-on is actually able to perform these actions using that feature.
Excellent. It looks like our cluster's up. Is there anything else that you wanted to touch on? I see that we've got a couple of questions that have come in. We've still got about 10 minutes though. So if there's anything else that you wanted to cover, whether it's things that are in the documentation, optional like modules, extensions, or different ways to set up the configuration here. Is there anything else that you wanted to share, Chetan?
Yeah, actually, there's a lot of features on the website, so I
Great.
can talk a bit more about the IRSA feature that I find it here.
Great. We'll get to the questions after you take us through the rest of it then.
Okay.
Thanks.
There you go. Yeah, this one. There's a lot. So this is one feature that every cluster admin should have enabled. So typically when you're running in an application in a Kubernetes cluster or any EKS cluster, you would, and if that application needs access to AWS resources, you would, for example, generate credentials and store them as secrets and pass to the container needing those credentials, or you would attach an IAM instance profile to the EC2 worker nodes, and then the container or pod will be able to assume that role. But none of those approaches are none of those approaches guarantee the principle of least privilege. So this is where IAM roles for service accounts comes into picture. So what it does is that it lets you associate an IAM role with a service account. So any pod, assuming that any pod using that service account will be granted an OIDC JSON wrap token that lets you access AWS that actually lets you assume that role and access AWS resources. This is what this section covers. I can walk
IAM roles is certainly, it's like a security best practice these days, right? I mean, I know that in the past we had to use things like dynamic roles or even, things like, static keys that got shared internally with people. So these IAM roles bake in a security best practice for provisioning and then accessing those resources on AWS. It's great.
So just to give an example, this is an example of creating an IAM role for service account for the cluster autoscale add-on, which is also used a lot. So all you had to do here was so EKS control has support for a lot of well-known policies. For example, for add-ons like autoscaler, the AWS load balancer controller, cert manager, and some others. So when you specify a well-known policy, EKS control automatically creates an IAM role for service account that creates a service account, an IAM role that has the policies required by the autoscaler service. And it doesn't deploy that for you because managing application workloads is not something that EKS control does. But when you deploy the cluster autoscaler, all you have to do is supply the name of the service account generated by EKS control, and it would automatically have, or it would, using the RSA feature, have access to the AWS resources it needs. Just looking for another feature that I can cover. So we do have support for a small GitOps related feature in EKS control. So in its current state, it only installs Flux for you. So you just installs and configures Flux for you. So you supply these options, and either doing cluster creation or using the EKS control enable Flux command, you can install Flux in your cluster. So this would be useful to have a single command that not only creates your cluster and infrastructure resources, but also deploys application workloads to them using Flux. Then we do have a lot, but I'll be happy to take questions now.
So the first question is, how can I make it work or cooperate with Terraform? Is there a relevant module or something to get this to work with Terraform?
So I remember there was an EKS control provider for Terraform that uses EKS control to provision resources. So it uses the EKS control binary or library. I am not sure, but I don't know if it's used a lot. So I think what some users do is manage the VPC and networking resources outside of EKS control and pass them to EKS control during cluster or node creation, and that way they get the best of both worlds, because usually users have a need to manage their networking resources using an infra as code approach, and not so much on updating EKS related config.
Makes a lot of sense. The next question is, will eksctl output CloudFormation templates upon its completion running? Or is this deployment not designed to be treated as infrastructure as code?
So that is that. So outputting a CloudFormation template or outputting Terraform config is one of the most requested features in EKS control. We could have probably done that, but it never got prioritized. So it's not straightforward to replicate the set of resources that EKS control creates using just CloudFormation or Terraform. Well, Terraform can do almost everything, but it's not just possible using just CloudFormation, because in addition to creating AWS resources, it also, in some cases, applies Kubernetes manifest and other things that CloudFormation is not capable of doing.
For people that have feature requests such as this, is there a place like the GitHub repo where they can go and make feature requests for this project?
Yeah, so it's care of, it's the EKS control repository in the EKS control IO of, I'm looking for a link. I know the URL, but I'm also looking for a link to that. Here it should be some. I don't know. So this is where we can open issues.
So yeah, please do make that request. I know that we partner with AWS, with Amazon folks to work on prioritizing the things that are going to be added from a feature capability standpoint. But we love to hear from users what's important to them and what they need. So by all means, please do request that in the repo or create a new issue for it. The next question that came in is, are we planning to support VPC subnets without having VPC and subnets provisioned up front? So I assume the ability to, take an existing VPC subnet that exists and not necessarily having to create a new one with the command.
I'm not sure I got the answer. Sorry, I'm not sure I got the question correct.
Sure. Let me read it back to you.
Yeah,
Are you
I'm reading
planning?
it right now,
Oh,
but,
great.
yeah.
Not sure if, yeah.
So if my guess is correct, it's asking if we can. Okay, so I'll give an example. So EKS control by default provisions the VPC. So the idea is that EKS control by default, EKS control by default creates the VPC and subnets, but if you have the subnets and VPC pre-created or provisioned upfront, you can pass them to EKS control using the VPC.id field. Was that the question?
Radovan, you can feel free to go ahead and just use another question to type yes, and then I'll clear your question if we answered it. If not, certainly feel free to put some more information in there to clarify the question for Chetan. While we're waiting for that, we'll move on to the next one. Now I can't use CIDRs in YAML for subnets. So he's looking to be able to use ranges in his YAML.
Okay, I think I got a question. So I think you're looking for the ability to configure the CIDRs for subnets before EKS control creates the subnets for you. I think I have seen a request for this feature before in the EKS control repository. It may not have been prioritized, I think. Or actually it conflicted with another feature that we have that lets you specify some pre-existing subnets with a given CIDR. But if you can open an issue in the EKS control repository with more details, we'll be happy to think about it more and discuss with the team.
That's great. Will has not a question, but a statement where, it says it deployed a stack, EKS CTL -demp -node group NG, and, just wanted to verify that. I guess that was what the example was doing.
Okay, so like I mentioned, EKS control uses CloudFormation for creating the control plane and the node group. So that log line, let me locate that here. No. Yep, so there's a deploying stack. So that log lines simply says that it has deployed that CloudFormation stack. Yes, well, that is correct.
Yeah.
You can actually check the CloudFormation template for the resources it created. But as I mentioned before, it does not let you just print the CloudFormation template because CloudFormation alone does not map to the set of features EKS control provides. So for example, if you created a cluster and used a feature that is not done through CloudFormation in EKS control, the output would not be complete. And that is one of the reasons why outcoding CloudFormation templates is not supported.
That makes sense.
I can answer the next one from Christian. So Christian is asking if there are any plans to provide the option to install Flux as an EKS add-on. So firstly, I would say that the add-ons feature in EKS control and EKS, the add-ons feature in EKS control is mainly for add-ons that are supported by EKS. And what I just showed with this feature that installs Flux v2 is not really considered an add-on in the context of EKS control. But the option to provide a native EKS Flux add-on has been discussed before. Like other features, it has not been prioritized. But it's possible we may hear soon about it next year.
And yeah, Christian, feel free to go to the repo and add an upvote to that feature. If you have any questions, feel free to reach out to us. We've got, community Slack and other things that we'll talk about towards the end of this. But I hope that answers your questions. It looks like Srinivasa figured out that you can use CIDR notation in the YAML. So
that is to clarify, that is the CIDR that is used for the VPC that EKS control will create. I think the previous user was asking if they can specify CIDRs for the subnets that EKS control creates, and that is something that is not supported. I hope that makes sense.
Yeah. All right. It looks like we're all caught up on questions at the moment. I know that we're about 10 minutes over time, which is a good thing. We love getting questions from everybody that's watching and learning about EKS control. But we're going to start wrapping it up now. So if anybody has a final question that they wanted to get in, please get it in now. You've got about 1 minute until we do that. Is there anything that you want to plug and talk about, Chetan, in terms of resources or, anything that's, upcoming in terms of changes or new capabilities or, things that you would recommend folks that are learning about it do, other than maybe, going and checking out the fantastic documentation that you and the team have put together for it?
So I'll be honest, the documentation could use some work because been going through it today. I felt that not everything might be clear for a new user. And as for upcoming features, I'm not allowed to share more details, but I would say that we have 2 major features coming up this month or next month. We have been working on at least 1 feature for months now. So, and that feature aims to simplify something that EKS has supported for a while, but it's not great. So that could be a major feature this year.
That's great. That's exciting, and continue to watch this space for more information about that. We got the one last question that came in again about Terraform or making it friendly to work with infrastructure deployments. Knowing that you can't really divulge and talk about things that aren't public information. But it sounds like this has come up maybe a couple of times before in the past. There's been questions about it, so I wouldn't be surprised if that is something that is planned for the future.
So like I mentioned before, one of the most upvoted features in the repository is support for outputting Terraform config in EKS control. It has not been prioritized, and one of the reasons for that is also, like I mentioned, as with CloudFormation, that Terraform may not be able to represent everything that EKS control does.
Yep, it makes sense.
But I have
Great.
seen some other users. I've seen some other users use both Terraform and EKS control. For example, you would have the networking resources created in Terraform, and using some sort of templating, you would generate a cluster config file that is this one, and substitute the VPC and other networking parameters, and then use that config file to pass to EKS control. But that I will bring this up again with AWS and the EKS control team.
It's great. We got a tip here from Radovan, who's having good success. It sounds like maybe using TerraGrunt to stitch those values into the provisioning module. So give that a shot. See if that will tide you over and make things work for you between now and when some new capability gets released. So I'm going to ask people, go check out eksctl.io. Look through the documentation, check out the repo, download and run eksctl on your favorite flavor of operating system, and try it. Put your hands on it and then let us know how we can make it better, how we can make it work better for you and for your organizational needs. I would also love it if everybody had a chance to go to weave.works and join some of the join this vibrant community of people that are supporting all of our open source projects that are so great. We've got a community Slack channel that you can join. There's lots of activity going on in there, whether it's talking about Flux and GitOps, or whether it's the use of tools like eksctl and other open source solutions. Thank you so much, Chetan. Anything else before we wrap up?
Well, there were a lot of other features that I could have demoed, but we don't have a lot of time, so I think this would be a good time to stop.
It's great. Well, I would love to have you back on Weaveworks office hours so we can explore more features. And it sounds like there might be a couple of big developments happening within the next month or two. That might be the perfect time to bring you back and have you demo some of the other features, talk about some of the new things that we're releasing, and give everybody an update on this.
Sounds good.
Awesome. Well, thank you so much for being with me today. Thank you to everybody that joined us today for our office hours. Thanks for all of the engagement and the interaction. Really happy to have you with us, and we'll see you next week. Thanks. Bye-bye.